friends, welcome to Physics with Ben. Don't forget to subscribe, like, comment, and share my videos. You may love to click in the description box below to watch a full video content on the concepts of motion. In that video, I explained what is motion, types, forces, the laws of motion, what is force. I also explained the various types of motion and their equation: linear motion, motion under gravity, projectile motion, and circular motion. And I promised in that video to use the equations in the video to produce calculations in all those types of motion. And this video is a fulfillment of that promise. So in today's video, we shall be looking at calculations in projectiles and motion under gravity. Stay tuned to the end and let's get the lesson started. So let's begin. If you are with your new school physics and also your calculations in physics, help me. Let's open to page number 137, exercise 2, book 2. I would like us to solve question number 7. I read: a stone propelled from a catapult with a speed of 50 meters per second attains a height of 100 meters. Calculate A, the time of flight; B, the angle of projection; C, the range attained. Very simple. So let's collect our data. Don't forget that I have taught you guys the 5 C's of calculations in physics. The first C is correct data collection, correct equation, correct substitution, correct evaluation, correct answer with SI unit, if any. So let's go straight to the point. This is question. This is question number 7. Question number 7. We know from the question that our U is given to be 50 meters per second, and our height, which is the maximum height attained, is given as 100 meters. We know that our time of flight capital T is not given. That is the A part. The B part, we have our angle of projection is also not given. We have the C part, we have the range of projection also not given. So if we may represent this question pictorially, this is what we have. Something like this: Y, this is our X, so this is the projection plane, and this is the object projected up here, and this up here we have our Vx, and then down here we have also our Vx, and down here we have our Vy, and then up here our Vy, and this is the horizontal velocity, the initial velocity U. This is the initial velocity, which is this, and this is the angle of projection theta, which is not given, and the range of projection from this point of projection so this point where the projectile hits the projection plane again, and the maximum height is given to be 100. So let's write down the equation that we need in this question. The time of flight T is given as 2u sine theta divided by g. We can't look for time of flight this point because there are 2 unknown at the same time. We have T not known and theta not known, so we can't make use of this equation. So we have our h is given as u squared sine squared theta divided by 2g. This equation also means that u square bracket sine theta all square divided by 2g. And then the range of the projectile r is equal to u square sine 2 theta divided by g. So the first things first we are going to do here, we are going to make use of this equation first to find our theta, because here just one unknown is not known. So let's go straight to the point. Here we know that our h is giving us u square into sine theta all square divided by 2g. We cross multiply so that we know that our u square into sine theta all square is equal to 2gh. We divide, so this implies that we divide both sides by 2gh. So if we do that, we have our u square into sine theta brackets square is equal to 2gh. Divide both sides by u square, both sides by u square. This will go and this will go. So we have our sine theta all square is equal to 2gh all over what? U square. We have our sine theta 2 times 1 over 2 is equal to 2gh divided by u square all to the power 1 all over 2. This and this will go. If you do that correctly, we are going to have our sine theta is equal to 2gh divided by u square. That is the root of that. That's it. But we are not looking for sine theta, but sine or theta. So we say theta is equal to sine inverse of the root of 2gh divided by u square. At this point, we substitute in the values. So we know that this is sine inverse of the root of 2 times 10. The value of g remains 10 meters per second square. So our h is given as 100. That is 10 times 100 divided by u square. U is 50. We have 50 square. If you do that correctly, we'll have sine inverse of the roots. This times this, that is 2000. That is 2000 divided by 2500. Let me confirm that. We have 2 times 10, 2 times 10 times 100. Yes, I was correct. Then we have 50 square. That is 2500. I was correct. So this go, this go, this go, this go. You are left with the root of 20 divided by 25. So 20 divided by 25, you have 0.8. So it implies that the root of 0.8, that will give us root 0.8, will give us 0.89. This is the same thing as 0.8944. So we find the sine inverse of 0.8944. If we do that, therefore, theta is equal to, let's shift sine 0.8944. That will give us 63 degrees. So we are good to go. So our theta here is at 63 degrees. At this point, we can find our time of flight right now. So our time of flight t is given as 2u sine theta divided by g. By substituting correctly, we have our 2 times 50 times sine 63 divided by 10. This is the same thing as, if you work that correctly, we have 2 times 50 times sine 63 times sine 63. That will give us 89.100 divided by 10. Divided by 10. And then we have, therefore, our time of flight is 8.9 seconds. That's our time of flight. How about our range? Our range R is given as U square sine 2 theta divided by G. What do we know of this? G. So we say that this is the same thing as U square is 50. So we say that 50 square times sine into 2 times 63. That's the meaning of this statement here. Divided by 10. Do that correctly, we have 50 square will give us 2,500 times sine 63 times 2, sine 126 divided by 10. If we evaluate that correctly, we have 2,500 times sine 126. That divided by 1 by 10. That will give us 202.2 meters. So our R is equals to this. As simple as ABC. As simple as ABC. So I may love to clean this and solve the next question. Are we good? Yes, we are good. Let us look at question number 12. This time is question number 12. I read. A body is projected upward at an angle of 30 degrees with the horizontal at an initial speed of 2,200 meters per second. In how many seconds will it reach the ground? How far from the point of projection will it strike? Solution. So we write that from there our data collection is theta is equals to 30 degrees and horizontal initial velocity u is given to be 2,000 meters per second. And then the action of time of flight is not given. Then the action of how far, meaning the range also is not what given. The range also is not given. So as we did in the other question, if we draw something like this to be a path of projection or projectile graph, this is the initial velocity u, which is this, and this is the projectile in flight, your vy, and then your vx, and then your v. The angle of projection is given to be what? 30 degrees. And so the range of the projectile, the height is not, the designer did not ask us to find the height here. They asked us to find, this is where the projectile lands, the R, the time of flight that you take to move from here to this point is not given. So let's go straight to the point. So the time of flight t is given as 2u sine theta divided by g. If we substitute, we are going to have 2 times 2,000 times 200, times sine 30 divided by 10. I guess this is 400. This is 400. 400 sine 30 should be 0.5. Let me confirm that. Sine 30, 0.5. This was correct. 400 times 0.5 divided by 10. So this will go, this will go. This is the same thing as 40 times 0.5. It simply means 40 divided by 2. 0.5 is 1 over 2. So that will give us 20 seconds. Yes, so therefore our t is what? 20 seconds. Let me confirm that. We have 2 times 200 times sine 30. We have that divide by 10. Yes, I was correct. So the next thing we have to do is to calculate the range of the projection. The range of the projection is not given. So we write that the range R is equal to U squared sine 2 theta divided by G. If we substitute, we have our U, we have 200 squared times sine bracket 2 times 30 divided by 10. So we have 200 squared, that will give us 40,000 times sine 60 divided by 10. This will go, this will go. So we have 4,000 sine 60. So we have 4,000 sine 60, and that will give us 3,464 meters. So the range of projection from this point to this point, the whole of this is what? 3,464 meters. This is the range of projection. And I hope we are done with this particular question. As simple as ABC. So let us solve a question from calculations in physics. I may love to claim this. Calculations in physics. So let's read page 119, exercise 2, question number 2. A ball is projected horizontally from the top of a hill with a velocity of 20 meters per second. Full stop. If it reaches the ground 4 seconds later, what is the height of the hill? What is the height of the hill? This is motion under gravity. The question looks like projectile motion question. So if I will collect my data correctly, this is question number 2 from calculation in physics. The ball is projected horizontally. This is how it looks like. So this is the hill. The ball is projected horizontally. The ball moves this way with horizontal velocity u, and down here vy, u, vy, and then it lands here. So from this point to this point is the height. Then from this point to this point is the horizontal distance s. This time not range, but horizontal distance. Good. I told you I told you that while on flight, the vertical component of the velocity is constant throughout the flight. So from here, the parameters that we have in question is the initial velocity u is given to be 20 meters per second. And so the time it takes this ball to move from here to here, that time t is given to be, four seconds. So what is the height? What is the height of the key? And then our g remains 10 meters per second squared. Remember I told you that for motion of gravity, we make use of this key. Do you remember this key? We make use of something like this. If you watch the other video, click in the description box below. You watch the video on everything I'm explaining right now. That when the ball is going up, your v is equals to 0, and your a is equals to minus g, and this is the height. When the ball is coming down, your u is equals to 0, and your a is equals to what? Plus g. So we are going to apply this here using the three equations of uniformly accelerated motion. Know that our h is given to be ut plus negative half gt squared. So the body is coming down. So it means that our initial velocity u is equal to 0. So the whole of this content is 0. So we write that our h is equal to plus negative half gt squared. However, the body is coming down, so we are not going to make use of the negative sign, but then the plus sign. So write a plus sign here. So this is the equation we are going to use to find the height of this cliff. So that our height h is equal to what? Half times 10 times what? Times 4. And you know that 10 over 2 is 5, and 2 here 1, 5 here 1. So 5 times 4 will give us what? 20 meters. So the height h is equal to what? 20 meters. As simple as ABC. Let me just confirm the results. Sorry. Yes, I did not square the 4. Yes. So if we square the 4, we have 16 there. I did not square my 4 here. So if you square the 4, we're going to have a different result altogether. So this is the same thing as 5 times 4 squared is 16. 4 squared is 16. 16 times 5 will give us 80. And so our answer times 16. Our answer is simply what? Our answer is simply 80 meters. And that is that for that. Yes, that is the answer. So let us move to the next question. Question number 3, page 119. I read again. An object is projected with a velocity 100 meters per second from the ground level at an angle theta to the vertical. If the total time of flight of the projectile is 10 seconds, calculate theta. Good. So this is question number 3. Question number 3, your all-inclusive calculation in physics. So our data collection, our U, this time I will not be drawing again. I'm giving you almost all the diagram to give you clarification on this topic. So we have our u is equals to 100 meters per second, and from an object is projected with this from the ground length, something like this. So we have our theta not given. Also, the time of flight t, if the total time of flight t is 10 seconds, and then theta is not given. As simple as ABC. So rather our time of flight t is equal to 2u sine theta divided by g. So we are going to cross multiply. So we have 2u sine theta is equal to what? gt. We will divide both sides by 2u. This and this will go, so that our sine theta is equal to gt over 2u. The sine inverse our theta is simply the sine inverse of gt divided by 2u. At this point, we substitute, so that we have our sine inverse of 10 . Don't forget that our g is always 10 meters per second squared. So we have 10 times 10 divided by 2 times what? 100. So we have 10 times 10, that is 100. 100 divided by what? 200. This we go, this we go, this we go, this we go. We are left with what? 1 all over 2. So this is the same thing as 0.5. So sine inverse of 0.5 will give us what? Shift 0.5. Shift sine 0.5. Shift sine 0.5 will give us 30. Are we correct? Let me check. Let me confirm that we have 10 times 10 equals to 100. We have 100 times 2. That's 200. So 100 by 200. 0.5 now. So our answer is 0.5. I think what we have here in the textbook is not correct. Yes, calculate theta to the vertical if the total time of flight is 10 seconds. So our answer is correct. So theta is equal to 30 degrees. That is that for that. So let's look at another question here quickly. Question number 4. I read. An object is projected with a velocity 100 meters per second at an angle of 60 to the vertical. Calculate the time taken by the object to reach the highest point. I will draw this one. May I claim this, please? Yes. So, question 4 reads, an object is projected with a velocity of 100 meters per second at an angle 60 degrees to the vertical. Calculate the time taken by the object to reach its highest points. So this is question number 4. So this is the diagram for the question. Your y and your x. The object is projected this way with u at an angle theta. And that angle theta is given to be 60 degrees. So the time to take the object to reach this highest point, where you have only the vertical component of the projectile. I told you in the other video that this time is given as small t is equal to what? U sine theta divided by g. And that is exactly what the examiners are asking of us. And so this u, this initial velocity u, is given, this your u is given to be 100 meters per second. That is that for that. We are not asked to find the range of the projectile. We are not asked to find the height of the projectile. We are just to find the time it takes it to reach the highest point. And so this time is given as t is equals to u sine theta divided by g. If you work it out, our u is given as 100 sine 60 divided, and our g remains 110 meters per second divided by what? 10. This row go left with 10 sine 60. So 10 sine 60 will give us 8.66. 100 sine 60 is that divide by 10. 100 u sine theta over g. I'm sure of that. 100 sine 60 is that divided by 10. So our answer is simply t is given to be 8.66 seconds. That is the time. That is the time to take the projectile to reach to this point. There are two ways of doing it. Either you calculate for time of flight and then divide the answer by 2. That is by saying t is equals to 2u sine theta divided by g. If you do that correctly, you're going to have 2 times 10 sine this divided by g. So you have 2 times 100 sine 60 sine 60, that is that divide by 10. So we got t to be equals to 17.3. So divide this answer by 2. Divide by 2. You'll still get the same answer. And so that gives you the small t. So the small t is t what? 8.66 seconds. And so if you have your calculations in physics, the answer there is wrong, totally wrong. And that is a typographical error, not from the publisher. So this is the correct answer. So we are going to be looking at the last question, and then we'll call it a day. We'll look at question number 5. May I clean this please? Yes. Okay, question number 5 reads, a stone is projected horizontally from the top of a tower with a speed of 5 meters per second. Full stop. It lands on the ground level at a horizontal distance of 20 meters from the foot of the tower. Calculate the height of the tower. So right again, this is question number 5. This is the top of the cliff. and then this is done with your U and V and V, Y, U and V, Y. This is where the stone lands. So the height of the cliff is not given. And so the distance with which it lands with, that distance S is given to be 20 meters. 20 meters. And then the U, the initial velocity U, which is constant throughout the flight, is given to be 5 meters per second. And then we are asked to calculate the height of the tower. And then our G remains 10 meters per second squared. So from H, I told you that when the water is going down, your U is 0. So we have our H is equal to UT plus half GT squared. Again, it will interest you to know that in this question, it covers a distance of that, and that. It will interest you to know that the time is not given. The time is not given. T is not given in this question. So we have our H is equal to U is already 0, half GT squared. This is the primary equation we are going to use. However, from velocity, V is equal to what? Distance all over time. And in this case, we are using initial velocity. So we write that our initial velocity U equals distance over time. So this implies that we must multiply our US is equal to what? T. So the time it takes this projectile to move from this point, from this height to the cliff to land in this space is given as what? Initial velocity times the horizontal what? Distance, S. So that is the same thing as what? 5 times what? 20. That will give us what? 100. So our T is given to be what? I was correct, 100 seconds. So the time it takes this guy to move from here to here is 100 seconds. Don't forget that physics will give you questions that will entail you to look for something before what you come back to it. So at this point, we can go ahead to find the height of the projectile. So we write that our height H is equal to half times 10 times 100 squared. This is the same thing as this and this. We have 5 times H is equal to UT plus half GT squared. And I want to confirm something quickly. The stone is projected horizontally from the top of the tower with the speed of that. If it lands on the ground level at a horizontal distance, this from the foot. 20. From the top of the foot, calculate the height of the tower, which is this. So velocity is distance over time. Oh, there's something wrong here. This was wrong evaluation. We have This over this is over 1. We have our S is equal to what? UT. Good. Our S equals to UT, and this implies that our T is what? S over U. S over U. Thank God I got it correct now. So our T is simply S over U means what? 20 divided by 5. And that will give us 20 by 5. Now 20 by 5, that is 4. Good. Oh, thank God, that is 4 seconds. So back here is what? 4 squared. So 4 squared is 16. Good. So this is 5 times 16. And that will give us 80. So the height is 80 meters. I'm deeply sorry for that confusion. Thank God I was able to spot it out, and this is all about it for today's video. Please don't forget to hit the like button, to share, to comment, and also subscribe to Physics with Ben. When else we meet, we shall be looking at calculations under linear motion and circular motion. Bye bye. God bless you.